In this video, we're going to talk about equations that result in a quadratic equation. So basically, as you're solving an equation, you end up having to solve a quadratic in order to answer the question. The four methods that we've learned to solve quadratics: we learned quadratic formula, the zero product property, the square root property, and completing the square. Three of these methods we learned in this chapter that we're working on. Previously, we had learned the zero product property back in chapter, I think it was 6. So the quadratic formula you can use for any quadratic. The zero product property, your quadratic has to be factorable. The square root property, you must be able to rewrite your quadratic as a perfect square that equals a number. And then completing the square, because we take the b in front of the x term, the number in front of the x term, and multiply it by a half, we have to have that bx term. We have to have that x term in our equation. If we don't, we can't complete the square. So if I had to order these hardest to easiest, I would say the square root property is definitely the easiest, followed by the zero product property if it can be factored. And then the quadratic formula is a no-brainer. After that, completing the square, if you really know completing the square well, completing the square can actually be easier than the quadratic formula. But I think when you first start off, completing the square is a little bit harder. Okay, so I would order them like that. So let's go ahead and start an equation. And this should look familiar to you. It has a square root in it, and we have been solving using the square root property a lot. So when we have a square root in a problem, how would you get rid of it? Well, if you had a square in a problem, you would square root it. If you have a square root, you have to square both sides. So we're going to take both sides and we're going to square it. Okay, so that means we're going to get rid of the square root. When you square root, it goes away. Just like when you take the square root of a square, it goes away. So now this looks like we have a quadratic because we have a nice square term. So we're going to subtract all of our terms to one side and decide what we're going to do. How we're going to solve this. X squared minus 9x minus 36 equals 0. So the first thing I'm going to look at is this factorable? And this one looks like it's factorable. What are the factors of negative 36 that add to negative 9? I would say it's negative 12 and positive 3. So I'm going to go ahead and set up my factors, negative 12 and positive 3. And then I'm going to get x equals 12 or negative 3. So now before I call victory, I have to plug these into my equation, because remember we said when you square both sides of an equation, you don't end up with you may not end up with an equivalent equation. So you could get solutions that are called extraneous. So let's plug in the 12 and see if it works. 9 times 12 plus 36. 12 equals 108 plus 36. 12 equals the square root of 144, which is 12 times 12. So I get to take that 12 out. So 12 equals 12. That one works, but does the other one work? I don't know. So let's see, let's plug it in. Equals 9 times negative 3 plus 36 equals negative 27 plus 36 equals 9. I know the square root of 9 is 3 times 3. I'm going to pull that 3 out. Negative 3 does not equal 3, so this one does not work. We end up with only one answer in this problem. So let's move on to the next one. So let's square both sides again to get rid of our square root. And remember, we have to check our answers. But this time we're going to square a binomial, right? So when we square this binomial, it looks like this. We have to FOIL. So we get 12x plus 12 equals, I know when I do this, I get x squared plus 2x plus 2x plus 4. So 12x plus 12 equals x squared plus 4x plus 4. So again, I'm going to set this equal to 0 before I decide on a method. So I'm going to subtract 12x from both sides, and I'm going to subtract 12 from both sides. And notice I line those up under their like terms. So I get x squared minus 8x minus 8. Well, there are no factors of minus 8 that add to 8, or that add to minus 8. So I'm just going to go ahead and, let's see, for this one, I think because this b term is even, I'm going to go ahead and use completing the square. So I'm going to move that minus 8 to the other side. I usually use completing the square when b is even and I don't have an a, right? A is 1. Okay, so remember I'm going to take that negative 8, I'm going to multiply it by a half and square. So I get negative 4 squared equals 16. I'm going to add 16 to both sides. So I get 24 equals x minus 4 squared. Okay, so now I'm just going to go ahead and take the square root of both sides. And I'm gonna move this around, and I'm gonna say x minus 4 squared equals 24. When I take the square root of x minus 4 squared, and remember we need that plus or minus, we get x minus 4. But what do we get here? Well, when we factor 24, 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. I'm going to bring out one of those 2's, plus or minus 2 radical 6. So now I'm going to set up my two equations. X minus 4 equals positive 2 radical 6. X minus 4 equals negative 2 radical 6. So I'm going to add 4 to both sides. And remember, 4 and negative 2 radical 6 are not like terms. So I'm going to just write each of these with their sign. Positive 4, and that is a positive 2 radical 6. This is going to be a positive 4 and a negative 2 radical 6. Okay, so we're going to just say both of these answers work, because I don't think I want to go ahead and plug those in. That looks horrible. Okay, all right, so now let's go ahead, and I went into the solving space of this other one. Okay, so when we have fractions in our equations, we want to multiply by the LCD. So I know that my LCD in this one is going to be x times x minus 7. All right. So I'm going to multiply every term on both sides of the equation to eliminate my denominator. So I'm going to take my first term here. I'm going to multiply it by the LCD. I'm going to take my second term here. I'm going to multiply it by the LCD. And then I'm going to take my term on my other side, and I'm going to multiply it by the LCD. So now I'm going to go and reduce the common factors. And lastly, I'm going to go ahead and distribute to remove my parentheses. So I get 2x minus 14 plus 5x equals x squared minus 7x. And I'm going to add my like terms on this side to get 7x minus 14 equals x squared minus 7x. Again, I'm going to set my equation equal to 0 so that I can pick a method for solving. So I'm going to subtract the 7x and add the 14. And I end up with 0 equals x squared minus 14x plus 14. And I know there are no factors of 14 that add to negative 14. So again, I'm going to go ahead and complete the square. I'm going to subtract 14 from both sides and leave this blank. And then I'm going to take this negative 14, I'm going to multiply it by a half and square it. So I get negative 7 squared is 49. I'm going to add 49 to both sides. So when I factor this left-hand side, I get x minus 7 squared. What's 49 minus 14? It's 35. And when I take the square root of both sides, I can't forget my plus or minus. And 35 factors into 5 times 7, so it's not going to reduce. So I get, and when I add the 7, right, if I break this up into two equations, which is what I should do, x minus 7 equals positive radical 35, x minus 7 equals negative radical 35. When I add that 7 to both sides, right, these are not like terms. I have a positive 7 and a positive radical 35. Here I have a positive 7 and a negative radical 35. Okay, so all I have to do is go up here and make sure I didn't get 0 and 7 as an answer, and I didn't. So I believe these are the right answers. Because remember, if I had gotten 0, it would have made this undefined. If I had gotten 7, it would have made this one undefined. Okay, so let's do this last problem. We're going to do the same thing. We're going to multiply by the LCD. And notice my x minus 5 is repeated, so I don't need it twice in my LCD. So let's go ahead and multiply each term by the LCD. And I know it's a lot to write, but it's a good thing to write it all out so you don't make a mistake. So now I'm going to reduce my like terms. And I get x minus 5 plus x equals x times x minus 4. And this is where I combine like terms and distribute. So I'm going to combine these terms to get 2x minus 5 equals x squared minus 4x. So let's subtract the 2x from both sides and add the 5. So I get 0 equals x squared minus 6x plus 5. Well, I know there are factors of 5 that add to 6, negative 6. So it's negative 5 and negative 1. Good. Okay, so this makes this one easy. We'll use the zero product property because we can factor this. X minus 1. So when I solve, I get x equals 5 and x equals 1. Well, what number can I have in my denominator? If I plug in a 5, 5 minus 5 makes my denominator 0. So I'm not allowed to have 5 as an answer. Can I plug in a 1? 1 makes none of my denominators 0. So I only have, even though I came up with 2 answers, I only have 1. Okay, so I'll do the next 4 problems on the next video.